Okay, ladies and gentlemen, I'm here to talk to you about worksheet number 2 from section 8.3. This is questions number 1 and number 2. Now, I had you copy this down, but let me go back over it real quick. A basketball player makes 70% of his free throws in a long season. Okay, so that's an established free throw probability. Now, as we go along, you read that he shoots five free throws in the game and misses 3 of them. The fans think he was nervous, okay? So what is the approximate probability that the player will miss 3 or more of the 5 shots? So that right there tells me that you're going to do 5 shots. And that's what we did down here. 5 shots, okay? Now, the simplest event is shooting the free throw. So we're looking for the probability that he misses the free throw, which is 0.3. So we're going to let 0, 1, and 2 represent missing a free throw. And this is a W, okay, a free throw. And 3 through 9 represent hitting a free throw. And then we're going to take 5 digits at a time to represent shooting 5 free throws. And then we're going to count the number of misses. Okay, now remember, as we talked about in class, you got to circle all the 0s, 1s, and 2s. I don't care about any other number, just the 0, 1, and 2. Now, in this case, in this first 5, there was a 2. That means out of these 5 free throws, he made 1. Out of these 5 free throws, he missed 1. And here he missed 0. In this simulation, out of these 5 free throws, he missed 3. So once you've gone through all 30, notice I didn't use all of them. So 30 stops here. All right, so now what we have is he had 0 misses in 7 of his simulations. He had 1 miss in 11 of his simulations. So now if you notice, 7 plus 11 plus 6 plus 5 plus 1 add up to 30. Okay? So 30 simulations. All right, so 30 events. Now, we're going to answer the question down at the bottom. Here, this is a binomial setting. So use your calculator to determine the probability of missing 3 or more shots out of 5. Is your answer reasonably close to the simulated probability? So we want to know that the probability that X is greater than 3, so that he missed 3 or more shots. Well, if you notice here, this is my simulated probability. So he missed 3 shots and 4 shots 6 times out of the 30 simulations. So that's a simulation of, or a probability of 0.2. So 20% of the time he's going to miss a shot, or 3 or more shots out of 5. Now, what we learned today was binomial CDF. And what you do, since we want this area to the right, so if I have 0, 1, 2, 3, 4, 5, all right, not 6, but 5, I want to know the probability that he misses 3 or more. So that means I want to find the CDF of 2. But I have to subtract it from 1 because I want this probability to the right. And so I go 1 minus binomial CDF, and I get 0.2, 2, 5, and 0.3 is my probability. So your K is 2, that's this right here. N is 5, and your probability is 0.3, and you get 0.1631. And it says, is your answer reasonably close to the simulated probability? This is close to that. So yes, they are relatively close. On problem number 2, again, we're picking an employee, okay? And the probability of picking a woman was 0.3. All right, let me minimize this a little bit. All right, the probability of picking a woman is 0.3. So you assign the digits of 0, 1, and 2. You run 30 simulations of 10 digits. Now remember, 10 digits represents 10 employees. All right? You pick the 0, 1, and 2 to represent picking a lady or picking a female. So 2 females out of 10, 4 females out of 10, 3 females out of 10. Now, once you have all your simulations done, you answer the question. Use your calculator to determine the probability of an employee employing 2 or fewer women. So only thing I did was I counted the ones that was 2 or less. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 out of 32 gave me a probability of 0.3438. Okay? Let me blow that up for you. So my simulated probability, the simulated probability is a 0.3438. Now, when I find the binomial CDF, because I want 0, 1, and 2, well, I want that right there. So I'm going to do binomial CDF of 2. My n was 10. My probability was 0.3. So I got 0.3828, which is not too far from the original 0.3438 of the simulated probability. Good luck with number 3 and number 4.